Hello and welcome to this video on projectile range, which is part of the Forces in Motion module in OCR A-Level Physics. So in today's lesson we're going to be looking at projectile range and how to plot the path of projectile objects. So if we've been successful and we've learnt in this lesson, we should be able to understand the definition and assumptions for projectile motion, detail the path of a projectile with and without air resistance, calculate the maximum height and range of a projectile. So in this lesson we're going to be looking at the following parts of the OCR A-Level Physics specification. 3.1.3 Projectile motion. So an object kicked or thrown in the air as a projectile will follow a parabolic path like the one shown below. Now if there's no air resistance acting on the object, we will assume the object follows a parabolic path. So this would mean that the path would reflect about its maximum height. Now we also know at the maximum height the vertical velocity of a projectile would be 0 meters per second. In addition, the time taken to reach the maximum height is half the time taken in the full journey. This is because the maximum height is reached at the halfway point of the journey. Now before the maximum height, the acceleration of the object will be minus g because it's going against the direction of gravity, whilst after the maximum height, the acceleration of the object will be g as it is following the direction of gravity. Now any projectile will follow a parabolic path. Now to work out values for the parabolic path, you resolve values at an angle into horizontal and vertical components. So if the object had an initial velocity of u, this can be resolved into its horizontal and vertical velocity. So in this example, the horizontal velocity will be u cos theta and the vertical velocity will be u sin theta. Now this is shown in the following. You'll note here that the vertical velocity is sine theta is equal to opposite over hypotenuse, which is the vertical velocity over the resultant velocity. So we can rearrange that to say the vertical velocity is the resultant velocity u sine theta. Now this comes from the idea of trigonometry, whilst the horizontal velocity is cos theta is equal to adjacent over hypotenuse, which is horizontal velocity over resultant velocity. So horizontal velocity equals u, the resultant velocity, cos theta, which once again, this comes from trigonometry. Now we can work out our resultant velocity by saying u squared is equal to the horizontal component squared plus the vertical component squared, which comes from the Pythagorean theorem. Now when we consider the path of the projectile, you can get the following paths. Now it's important to note that air resistance acts in the opposite direction to the motion of a projectile. So the air resistance increases as the projectile's speed increases. So the air resistance reduces the horizontal component of the velocity and the horizontal displacement, which is also called the range. Now the air resistance reduces the maximum height of a projectile, and the air resistance makes the descent steeper than its ascent. Now you'll note here the path of a projectile if there was no gravity or air resistance present. Now if gravity did not exist, the projectile velocity in the horizontal and vertical is constant, which gives the following displacement. The horizontal component is equal to ut cos theta, and the vertical component is ut sin theta. Now this links back to the resolving of velocities earlier. If gravity did not exist, then the velocities would remain the same throughout. So displacement is velocity times by time, or ut. Now if we bring back gravity into the consideration, this brings the position of the object down vertically as it moves the object lower. So now our horizontal component is ut cos theta and our vertical component is ut sin theta minus a half gt squared. So this means that the vertical velocity is calculated via the equation v equals u plus at, but v is equal to u sin theta, our vertical component, minus gt because acceleration is equal to minus g. Now the horizontal component gives the range of the projectile, and this is calculated with the principle that range is equal to speed times by time. Now this occurs as there's no resultant force acting on the object horizontally. So remember the following. Vertically, the object experiences a constant velocity, whilst horizontally, the object experiences a constant velocity. Vertically, values can be calculated using the Suvat equations, whilst horizontally, the values can be calculated using the equation that velocity is equal to displacement divided by time. Now, the vertical component of the velocity is equal to u sine theta, whilst the horizontal component of the velocity is u cos theta. Now, when we include gravity into this, and we include the idea that it will be acting on the object, we can say that v is equal to u sine theta minus gt for vertically, whilst horizontally, because there's no effect of gravity horizontally, v is equal to u cos theta equal to displacement over time. So therefore, what we can say is that the vertical displacement is equal to ut sine theta minus a half gt squared, whilst the horizontal displacement, or the range, is equal to ut cos theta times by t. Now, in both the vertical displacement and the horizontal displacement, they would both be reduced if air resistance was present on our projectile. So let's consider the following example of calculating the height of a projectile. An arrow was fired at a velocity of 48 meters per second at an angle of 30 degrees to the horizontal from a height of 1.5 meters. The arrow hits a target at the same height 0.25 seconds later. What is the maximum height above the field gained by the arrow, and what assumption has been made? So, how will we answer this question? Well, the vertical displacement is equal to ut sine theta minus a half gt squared. We've just said that. So therefore, it's equal to 0.25 times by 48 sine 30 minus a half times by 9.81 times by 0.25 squared, which is 5.7 meters. So therefore, the arrow has gone up because we've projected it upwards. So therefore, it's 1.5 plus 5.7. So therefore, our answer is going to be 7.2 meters. Right, so to summarise what we've learned in today's lesson, we've looked at the independence of vertical and horizontal motion of a projectile. We've looked at the two-dimensional motion of a projectile with a constant velocity in one direction and a constant acceleration in a perpendicular direction. So if we've been successful and we've learnt in today's lesson, we can understand the definition and assumptions for projectile motion. We can detail the path of a projectile with and without air resistance, and we can calculate the maximum height and range of a projectile. So, thank you so much for watching this lesson on projectile range, which is part of the Forces of Motion module in OCR A-Level Physics. Thank you so much and have a lovely day.